we're going to take a look at curve sketching specifically. So this is a video where we're going to take all the concepts that we have done on finding intervals of increasing, intervals of decreasing, relative mins, relative max, concave up, concave down, inflection points, plus tie in some old stuff from Algebra 2, such as the domain of a function and the x-intercepts, with a little bit of limits as x goes to infinity for the end behavior, and tie it all together to make a nice detailed graph. So the first thing I would want to do is talk about the domain. So my domain here, sorry, let's turn that cursor off. My domain here, because it is a polynomial, is all real numbers, or negative infinity to infinity. Okay. So this is not factorable, so I'm not going to find any x-intercepts. You can see it's not groupable, it's kind of a bit of a mess. There is no symmetry happening, and when we're talking about symmetry, this is thinking about whether I have either an even function or an odd function, and that if I have symmetry, an even function would have symmetry over the y-axis, kind of like a parabola has that. It could have it, like x squared plus 4 has symmetry over the y-axis, or an odd function like just a regular x cubed has symmetry over the origin. Okay. This has no asymptotes. So now I'm going to get into my intervals of increasing and decreasing. So the first derivative here is negative 3x squared plus 18x minus 15. So to find those intervals of increasing and decreasing, we're going to set that derivative equal to 0 and solve. So I like to divide by a negative so that I have a positive. And then a little factor, x minus 5, x minus 1. So that's telling me that potential local maxes and mins are occurring at 5 and positive 1 because my critical numbers are 1 and 5. So now I'm going to figure out my intervals of increasing and decreasing. So we're talking negative infinity to 1, 1 to 5, and 5 to infinity. So my first derivative, and again, my first derivative is this. Is that going from negative 1 to negative infinity to positive 1, is that going to be positive or negative? So you can test a value like 0. I'm going to get 0 plus 0 minus 15, and that results in a negative. So that is decreasing. Something between 1 and 5. So like 2. When I plug in 2, I'm just going to do a quick little plus 18 times 2 minus 15. You could also plug it into a factored form with that negative 3. If you plug into the factored form, you need to make sure you plug into the one with a GCF pulled out, not where I divided. That comes out as a positive, because here I have negative 12 and a minus 15, and 2 times 18 is definitely going to be bigger than it. Again, remember when I'm plugging in, I'm less concerned about what the actual output is and more concerned on whether it's positive or negative. And then when I plug in something bigger than 5, like 6, I am going to end up with a negative as well. So this is increasing and this is decreasing. Okay, so if I talk about intervals of increasing and decreasing, we are decreasing from negative infinity to 1, union 5 to infinity, and I am increasing from 1 to 5. This also means that by the first derivative test, since I'm changing from decreasing to increasing, I have a local min at 1 comma something, and a local max at, as I'm changing from increasing to decreasing, that's going to be a local max at 5 comma something. Notice I left those y value coordinates blank, because I'm going to go back to my original function, x cubed 9x squared, y equals negative x cubed plus 9x squared minus 15x plus 2. And I'm going to plug into the original one for this. So y1 is going to be negative 1 plus 9 minus 15 plus 2. So negative 16 plus 1 is negative 5. Then when I plug in 5, oh boy, that's going to be large and in charge. Okay, negative 5 cubed plus 9 times 5 squared minus 15 times 5 plus 2. Negative 125. So this is 9 times 25. So then I have 225. And when I do that out, I get 27. When I go back to here, I wanted intervals of increasing, decreasing. Oh, I didn't list on my list local extrema, but I want those two. So I found my intervals of increasing and decreasing. I found my local mins and maxes. Next, I want to find my concavity. So again, so there's my first derivative. So now my second derivative, okay, just make sure it's going, is negative 6x plus 18. Okay, so let's find the critical numbers on that. Now here, a critical number means it's going to have the potential to be an inflection point, but doesn't have to be an inflection point. X comes out as 3. So what we're saying here is negative infinity to 3 and 3 to infinity are my intervals, and my second derivative, when I have between negative infinity and 3 like 0, that comes out as a positive. And then if I have bigger than 3, that's going to be a negative. That's telling me that we are concave up from negative infinity to 3, and we are concave down from 3 to infinity. Now, because you can see that change in concavity from being concave up to concave down, that tells me that I have an inflection point. Now again, remember the second derivative equaling 0 just gives me the potential for 1, but the fact that it does actually change concavity from positive to negative, that's what tells me that we will actually have an inflection point. Now I need to find the y value of my inflection point because my whole goal here is to sketch this actual curve. So I'm going to type this, figure this out. My pulled negative 7, 81, 5, 2. And this survey says this comes out as there's my inflection point. So going back, we have now found our points of inflection, both increase and concavity. And those are all things I found with calculus. Now I'm going to take this lovely piece of graph paper and create my sketch. I need to go all the way up to a positive 27 and down to a negative 5 for the local min and local max. I'm going to put my wire, let's make it a little. Right. So on this axis, I'm going to go by 2s. 2, 4, 6, 8. Okay. 2, -4, -6. All right. So what we've got, and I'm going to go by ones on these. So I am doing a different scale on my x than I am on my y. So 1 comma -5 and 5 comma 27. And then I also had an inflection point at 3 comma 11. So again, that inflection point is going to shape these pieces. Okay, down. And this up. The other thing I would say, we do know that our y-intercept on this should be positive 2. So that's going to help me shape. Oh, almost took over the mic. That'll help me shape this to say, I know I have to cross there. I'm going to kind of dip pretty fast and come back up. Depending on what I had, I did not find the x-intercepts on this one because it was not factorable, but if I had something that was factorable, I would find those as well. And that's my graph. So the whole idea here in curve sketching is these mins and maxes that we kind of hand-waved in Algebra 2, we can actually find them more accurately now that we can do calculus, and we can find them by hand and not just rely on Desmos or our graphing calculator. This concludes our